Okay, we're going to look at a couple of questions now with regard to range, outliers, and your trimmed mean. So we're going to look at identifying the range, outliers, calculating trim mean. So here we go to start. A multiple choice question. Which of the following is not true about an outlier? Is it that it is a value that is very different from the other values in a data set? Is it that B, it should always be removed from a data set before determining measures of central tendency? Is it C, when computing the trim mean, outliers are removed from the data set? Or is it D, a data set may have 0, 1, or more than 1 outliers? Well, that D is definitely a true statement. A data may have none, 1, or more than 1 outlier, so it's not going to be D. We know for certain that we could have 0, 1, or many outliers. An outlier is a value that is very different from the other values in a data set. So that is exactly what A tells us. We know it's an outlier because it is so different from everything else. And it is most definitely true that when computing a trimmed mean, the outliers must be removed from the data set. So it can't be C. So by process of elimination here, we've calculated that it must be, or we've identified that it must be B. It should always be removed from a data set before determining measures of central tendency. Is that actually true? Well, we looked at our example with Wayne Gretzky in the lesson, and we saw that it depended on the situation, right? If we wanted to show how much better Wayne Gretzky's year was than anyone else's, then we wouldn't want to remove his data. We'd want to show how much of an effect he has on his measures, the measures of central tendency, compared to anyone else. So in a situation like that, we wouldn't necessarily want to remove the outlier. So the answer is B, that it is not true that we always remove the outlier. It should sometimes be removed, depending on the situation. That would make it a true statement. Okay, so it's not necessarily true that we always remove it. Sometimes we do want to include that in our evaluation. Okay, here we have an example. The weights of 10 lobsters caught were recorded in pounds. So we have lobsters from 1.5 to 1.4, 4.1, 1.5, 1.6, 2.1, 1.4, 1.1, and 1.2. What is the range of the data set? We got to identify the lowest value, the least value in our data set. In this case, that's going to be 1.1. And we also have to identify the greatest number in our data set, and that would be 4.1. So my range is going to be equal to my greatest number minus the least number. Okay, so my range of values is 3. They differ by as much as 3 pounds overall. What are the 3 measures of central tendency? Well, to do that, we have to first, for mean, recall that we have to add all our numbers together and then divide by the total amount of numbers. So that'd be 1.5 plus 2.0 plus 1.4 plus 4.1 plus 1.5 plus 1.6 plus 2.1 plus 1.4 plus 1.1 plus 1.2, and divide all that by 10. So that for me works out to 17.9 divided by 10, which is 1.79. So my mean value is 1.79. So the average is 1.79 in other words. For my median and my mode, the first thing I'm going to want to do is put my data from least to greatest. So for that, I'm going to start with my smallest number, 1.1. Then I'm going to have my next smallest, 1.2. Then I'm going to have my next, which is 1.4. Then 1.4 again. Then 1.5. Then 1.5 again. Then I have 1.6. Then I have 2.0. Then I have 2.1. And finally, I have 4.1. Okay, so I have my data put in a numerical order from least to greatest. To find my median, I'm going to have to find the middle of that data. So I'm going to cross off one at a time. I'm just going to underline again. I don't want to completely take away the ability to see the numbers. So I underline first the two outer numbers. Then I go one in from each end. And then continue to do that until I get to the middle. All right, so what I notice is that once again I have 10 data points. So that means my middle number, my median, is between two numbers. To find my median in a situation like this, I'm going to have to add my the two numbers on either side of that middle line there, and then divide by 2. So my median is going to be equal to 1.5 plus 1.5 divided by 2, which is equal to 3.0 divided by 2, which is equal to 1.5. So my median value is equal to 1.5. Well, I didn't write down what my mean was, even though I said it. So my mean is equal to 1.79. My mode is the most commonly occurring number. Well, notice that 1.4 appears twice, and 1.5 also appears twice. Every other value is there once. So I'm bimodal. I have two modes. So my mode is going to be 1.4 and 1.5. So again, it's bimodal, because I have two modes. So I'll write that over here as well. Mode is equal to 1.4 and 1.5. Identify any outliers. Should the outliers be removed when advertising the average weight of the lobsters this season? Explain. So are there any outliers here? Well, when we have our data set up in numerical order, it's very easy to see. The difference between weights is first is 0.1, then 0.2, then 0, then 0.1, 0, 0.1, 0.4, 0.1, and then 2. So 4.1 is way larger than anything else. So 4.1 pounds is an outlier. Should the outlier be removed when advertising the average weight of the lobsters this season? Yes, it should. The reason is, when you're looking at an average weight, most of the lobsters are within 1 and 2 pounds. by having one lobster that's 4 pounds, 4.1 pounds, it means that your average, your mean amount is going to go way up. So it's false advertising to say that we have an average weight of 1.8 pounds, when in fact, if we look at our list, there are in fact only, of the 10 lobsters caught, there are only 3 lobsters that are actually larger than 1.79 pounds. So it's false advertising to say that the average would be 1.79. Only 3 lobsters are actually larger than the current mean. So only 3 lobsters are larger than the mean if the outlier is included. There's only one outlier here as well, right? It's only the 4.1. Oops. Only the outlier is included. It gives us an unfair representation of the size of the lobsters. It gives an unfair representation of the size of the lobsters, of the average size of lobsters. Okay, so remove the highest and lowest values and recalculate the range, median, and mean. So if I remove the highest and lowest values, now my lowest value is going to be 1.2. Then I'm going to have 1.4, oops, I'm going to start that one over again. One 1.4. Then I had 1.5, 1.5, 1.6, 2.0, and 2.1. So I have now only 8. Whenever I'm doing a trimmed mean, I have to remove the highest and lowest together. I have to be fair to both ends of my data here. So these are my new values. So my range now is from 2.1 down to 1.2. So from 2.1 down to 1.2 gives me a range of values of 0.9 pounds. So the greatest difference between my lobsters now is only 0.9 pounds as opposed to 3 pounds originally. The big change there. My median is still going to be 1.5. I've cut off one piece from the lowest end and one piece from the highest end, so my median is not going to change as a result. My mean will change, though, dramatically. So for my mean now, I'm going to add 1.2 plus 1.4 plus 1.4 plus 1.5 plus 1.5 plus 1.6 plus 2.0 plus 2.1. And now I'm going to divide that by 8. And now the numbers will add up to 12.7, and I divide that by 8. And it gives me an average value of 1.59 pounds. So my mean value has gone down by as much as 0.2 pounds overall, which is a big change. I'm going to show you a second way of calculating your mean. We knew that the sum of the first 10, when we didn't take away our highest and lowest values, we had a sum of 17.9. Well, I'm going to take away my highest and my lowest values, and that will also give me 12.7. So that would once again be divided by 8 because I've removed 2 terms, and I'm going to get again 1.59 pounds. So it's a second way that you can calculate your trimmed mean. This is a trimmed mean in this case. How did removing the highest and lowest values affect these measures of central tendency? Well, the range was originally 3, and I'm going to call it, it's not officially called the trimmed mean, but that's what I'm going to call it for now, was 0.9. My median originally was 1.5, and later on it was 1.5. My mean was 1.79, and now the trimmed mean, this is actually the trimmed mean, is 1.59. So, range was reduced dramatically. The range is reduced by 2.1 pounds. The median is unchanged. And the mean was reduced by 0.2 pounds a lobster. So it did have a big effect. So to summarize again, the range is the difference between the greatest and least terms in a set of data. An outlier is a number in a data set that is much larger or smaller than the others. Outliers may be due to errors or odd events. In this case, either the lobster was much older or was much stronger than the others, and so was able to dominate for more food, and it grew dramatically bigger. It was almost twice as big as any other lobster caught, the 4.1 pound one. And a trimmed mean is a way to calculate a mean by removing outliers. But when we remove outliers, the same number of terms must be removed from the low end and the high end of a set of data.